Hello and welcome to Math with Mrs. Becker. Today in calculus we are looking at section 4.2 where we will find the derivative of exponential functions using secant lines. So if you notice, all of these graphs are exponential functions. When you graph them, you always get a curve shape. Every single graph will touch at the point 0, 1 because any exponent to the power of 0, so like 5 to the power of 0 would be 1. 2 to the power of 0 would be 1. 1.1 to the power of 0 would be 1. That's why all of these lines do have that 1 point in common. Now what happens though is every single slope is different. So if I go ahead, I'm going to grab some fun colors here. If I look at 5 to the power of x, it has a pretty steep slope at that point. If I look at y to the 2x, it still has a positive slope but not as steep. 1.1, that's almost horizontal. Okay, so what happens is all of these different curves have a different slope at that point 0, 1. Because of that, they use that idea and they were able to figure out a formula to find a derivative for an exponential function. So if I look at this, when you have y equals 2 to the power of x, its slope is approximately 0.693. Now that's just going to be given to you. You don't have to worry about calculating it. That is the slope at 0, 1 of this curve right here. Okay, when you look at y equals 3x, which is actually not on this graph, the slope there is 1.1. So notice 0.693 is less than 1. 1.1 is greater than 1. So there's a number somewhere, a base that's between 2 and 3, where the slope would be 1. That occurs at e. So e is the base. Its value, it is an irrational number just like pi, continues forever and ever. Here are just the first 10 digits. Typically when you talk about e, they round it and just use 2.7. Like for pi, we use 3.14. But e is the base, where if you graph e to the power of x at the point 0, 1, the slope is exactly 1. So it's kind of cool. So what they're doing here to figure out the derivative is they're revisiting the idea of a secant line. Now remember, a secant line is a line that touches a curve at 2 points. Now we look at the h as being the horizontal distance. If I go ahead and let's just say this is my point 0, 1. If I want to know what the slope is at 0, 1, I would move this point, the horizontal distance, closer and closer and closer. And as I get closer, it would approach that slope. So that's what this formula is saying. Again, it's the whole idea of limits. But for us, they are going to give us the slopes, which is kind of nice. But here's what the derivative is. This is it. If I want to find the derivative of 2 to the power of x, you take the slope of 2 to the power of x at the point 0, 1, and you multiply it out front. So the slope of 2 to the power of x is 0.693 times 2 to the power of x. That's the derivative. If I wanted the derivative of 3 to the power of x, because the slope at 0, 1 is 1.1, the derivative is 1.1 times 3 to the power of x. It's just whatever the slope is at that point times the function itself. So the cool thing, if I have e to the power of x, the derivative of that is 1 times e to the power of x, which is just e to the power of x. So it's so cool. E to the power of x is its own derivative. So that is what the formula is. Now remember, when they start having us do derivatives, because we are just attaching a slope, oftentimes they'll have us fill in a number at the end. So this line means after you find the derivative, then go ahead and fill in the number. So the derivative of 2 to the power of x is 0.693 times 2 to the power of x. That's the derivative. Now that we have it, change the x to a 3. So 0.693 times 2 to the power of 3. Now here, all you're doing is calculating that. So I have 0.693 times 2 to the power of 3, and the value is 5.544. That is it. Next, same thing, derivative of 2 to the power of x first. The slope of 2 to the power of x at 0, 1 is 0.693 2 to the power of x. That's the derivative. Now they want us to find the value if x is replaced with a -1. So 0.693 times 2 to the power of -1. This is something you just fill into your calculator. So I go up here, and where I have a 3, I replace it with a -1. It is 0.3465. Quick and easy. So again, this is what the formula is, and it works for any exponential functions. Whatever the slope is at the point 0,1, that's m. Then you just rewrite the function. Okay, so that's pretty cool. When it's 2 to the power of x, we use 0.693. When it's 3 to the power of x, we use 1.1. If it's e is a 1. Those are the only 3 that we will actually look at. The cool thing, 1 times e to the x is e to the x, so the derivative of e to the x is e to the x. That makes a lot of these derivative rules that we've been using a lot easier than when we're working with numbers. Turn to the back. So if I want to find the equation of a tangent line, and I have y equals e to the power of x, and we want to find the equation of the line at x equals 3. In order to find the equation of a line, you need 2 different things. Step 1 is you need a slope. Step 2 is you need to have an ordered pair. So I have the x. X is a 3. To find y, you fill it into the original. So it's e to the power of 3. So if I go into the calculator, if you look right above natural log, you'll see that there's e. So second natural log gets you e. We want to the power of 3. Let's round it to the 100th. So it would be 20.09. So that is my ordered pair, 3 and 20.09. Now if I want to find the slope, the derivative of e to the x equals e to the x. So that's the derivative. Now to find the slope, you take the first derivative, fill in your x value. So my derivative is e to the power of x. If x becomes a 3, we already calculated e to the power of 3, and we found it to be 20.09. So the slope is 20.09. My ordered pair is 3 and 20.09. So now I can go ahead and make an equation. Y minus the y value from the ordered pair equals the slope, 20.09. X minus the x value from the ordered pair. Distribute the slope. Y minus 20.09 equals 20.09 times x minus, if I take 20.09 and I multiply it by 3, this is 60.27. Last step, I need y by itself. So I would add my 20.09 to each side. Here I'm combining the like terms. So y equals 20.09x. This is a negative 60.27. If I add 20.09, I'd have negative 40.18. That is the equation of the line, or in this case it's a curve, e to the power of x at x equals 3. If you draw a tangent line, that line would have this equation. Kind of cool. Now if you are trying to solve equations, remember if you are trying to cancel an e, what you need is a natural log. A natural log and e are inverses or opposite of one another, so as soon as they touch one another, they completely go away, okay? They undo one another. So if I want to solve a couple equations, just to remind us how that works. Right now, I cannot take the natural log of each side because that 4 is in the way. Step 1, divide 4. E to the power of 6x equals 80 divided by 4 is 20. Now that the e is out front, I can cancel it by taking the natural log. What you do to one side, you always do to the other. Natural log and e cancels. 6x equals, now I have to calculate natural log of 20 because that's what I have on this side. So I have 2.9957, we'll go 2.996. Last step, if I want to solve for x, I have to divide by 6. So 2.996 divided by 6, it's approximately 4.993. So I solved by canceling an e using a natural log. Here's one more just to remind us how that works. If I want to cancel an e, natural log of each side. Natural log cancels e, so 3x equals natural log of 18. So natural log of 18 is 2.89. To solve for x, divide both sides by 3. So 2.89, if I divide it by 3, I have 0.963333, so we'll just put 0.963. So there's how you can solve equations that have an E. Now this is going to be very similar to what we did yesterday. You had to get everything into the form 2 to the kx, or in the homework you could also do 3 to the kx. Now they want us to use those exponent properties, but our base is E. So your base is E, you can have one number in front of x. If you have one base and two exponents, remember you multiply them. So this is e to the 4x. E is on the bottom, so this is really e to the negative power of 3 times x. Inside exponent, outside exponent, so this is e to the negative 3x. If you have the same base and you're multiplying, you write the base once and you add the exponents. So I have 3 minus x plus 4x minus 3. In this case, what I need to do is combine any like terms. So e, negative 1x plus 4x is 3x. Positive 3 and a negative 3 cancels, so that would be your final answer. So there's how you can simplify so you only have one base. Now these are derivatives. If you have a derivative with e to the power of x, remember here you can use what's called the constant multiple rule. I can take the 5 out, then I could take the derivative of e to the x for that first term. So it's 5 times the derivative of e to the x is e to the x minus the derivative of 9x is just 9. 5 times e to the x is 5 e to the x minus 9. Next one. This is not the quotient rule. Quotient rule comes when you have letters on the top and letters on the bottom. If it is just a number on the bottom, that is constant multiple rule. So what I have to do is take that 1/4 out front. So 1/4, now find the derivative of the top. 2x plus 4 minus 5 e to the x. So 1/4 is out front. If I find the derivative of 2x, that's just a 2. Derivative of 4 is 0. Here, this is the same thing. I can take negative 5 times the derivative of e to the x. Well, the derivative of e to the x is e to the x, so when you multiply it back to the negative 5, it remains exactly the same, which is kind of cool. Now, I have to bring these back together. I can just take this 4 and put it back on the bottom. So 2 minus 5e to the x over 4, that's your derivative. So both of these just show you how you can use the constant multiple rule. It is going to end up being the same thing. 5e to the x, the derivative is 5e to the x. Negative 5e to the x, the derivative became negative 5e to the x. But that occurred because of that constant multiple rule. You could take it out, find the derivative, multiply it back in. Okay, now the next one. In order to find the derivative of this, you have to use the product rule, because I have two different things being multiplied and they both contain an x. Product rule, f of x is the first thing, so we have an x squared plus an x plus 1. G of x is the second thing. In this case, we have e to the x. Product rule is in those big chunks. So my first chunk, you keep f of x the same. X squared plus x plus 1 times the derivative of g of x. Derivative of e to the x is just e to the x, plus keep g of x, e to the x the same, times derivative of f of x, 2x plus 1. Now product rule is where you look and say, okay, what do they have in common? Both of these groups have an e to the power of x. So e to the x comes out front. That would be gone, that would be gone. What I have remaining is x squared plus x plus 1 plus sign 2x plus 1. Now we just simplify what's inside of the brackets. So e to the x, x squared. I can combine like terms. 1x and 2x makes 3x. 1 and 1 makes 2. That is the derivative of this. So sometimes you will need to use the product rule. Now D, we do have to do the quotient rule. Quotient rule because I have letters on the top and I have letters on the bottom. So when I go to do this, remember the top is always f of x. So x plus 1. G of x is always the bottom. Start off with just the top. G of x stays times the derivative of f of x. That's the first chunk. Minus f of x stays the same times the derivative of g of x. Now here, I want to simplify each bracket. Right now, just kind of looking ahead, this is one term times 2. So this e to the x does have to go to both terms. 1 times e to the x is e to the x minus x times e to the x is x e to the x plus e to the x times 1 is e to the x. I am minusing both terms. So I distribute the negative. Now I simplify. Notice here, here's a positive e to the x and here's a negative e to the x. They cancel one another. So the numerator is negative x e to the x. The bottom, take g of x squared. So if I had this and I squared it, properties of exponents. Inside and outside, you have to multiply them. That makes it e to the 2x. Now last step, I can simplify. This means I have 2 e to the x's. This means I have 1. I could cross this one off, which would cancel the 2. So my final answer and your derivative is negative x over e to the x. And that is section 4.2. Here is the suggested assignment. I hope you're having a great day, and I'll talk to you soon.